Alright, welcome back to Module 6 of Networking Fundamentals. We're going to go ahead and get started here with understanding Internet Protocol, or IP as everybody like to call it. Alright, so let's take a quick look at our agenda. We're going to go ahead and cover several objectives. Alright, understanding IPv4, alright, and we're going to talk about the address and categories for the protocol. And we're going to talk about network address translation. And then we're going to move on to discuss default gateways and DNS servers, right? And then finally, we'll touch on subnetting and CIDR, right? Then lastly, we'll go ahead and touch on IPv6 as well as a protocol. This is the ultimate replacement or eventual replacement for the IPv4. The Internet Protocol resides on the network layer, as you can recall from our detailing of the OSI model, right? So IP addresses are used to help devices send and receive data across the network. Now, remember that they are very much like our mailing address. So if you mail something to someone, right, like your family member or your friend, well, it's the same way computers communicate, right? They use addresses in order to make sure that the information goes to the intended destination. Now, IPv4 currently is the most commonly used communication protocol, right? But IPv6 is starting to replace it, right? It's already being used more and more widely everywhere. Alright, so let's talk a little bit more about IPv4, right? Now, this is the fourth version, and that's why it says v4, right? But it's the first version, though, that the IP protocol is widely used, right? IP addresses, I'm sure you noticed this, consist of 4 octets, right? So we have 1, 2, 3, 4, right? We have 4 different examples here on the right, and each has 4 octets. Now, each octet is separated by a decimal point. You may refer to this as a period, but call it a decimal point for this sake, right? Now, each octet represents 1 byte or 8 bits, meaning that the IPv4 address features 32 bits. Alright, so let's move on and talk about IPv4 categories. Now, they've been separated into 5 different classes, right? Now, the classification system is called classful addressing or classful network architecture. And in this system, the first octet of the IPv4 address defines which class the address belongs to. So if the first octet is in the range of 0 to 127, then it belongs to a class A, okay? And if it's in the range of 128 to 191, then it belongs to a class B, and so on and so on. Now, I want you to look to the chart that I have here on the right of the screen, okay? We have the classes, class A, B, C, and D, and then we have the IP range, right? The first octet that will define the class. This is very important for you to note, so take some time to look at this chart and find a way to memorize it. Alright, so one thing about Class A is that there is a reserved network address for loopback IP addresses, right? And loopback IP addresses are used for testing and ensuring that your network adapter is properly functioning. So every device is automatically assigned the 127.0.0.1 loopback IP address. Alright, so IP addresses have subnet mask, and we talked about this a little bit earlier, right? Each IP address has a network portion and then a node portion, right? Just for reference sake, node is another word for host, by the way, right? You'll hear these terms being used interchangeably. Now, with a Class A address, the default subnet mask is 255.0.0.0, and so that means that if you have a 255, that portion belongs to the network, In contrast, if you have zeros, then that portion belongs to the host or the node. Okay, so that helps uniquely identify a host or a node, right? Similarly, we take a look over here at the subnet mask for a class C address, right? Now, the first three portions are dedicated to the network. So that information in the IPv4 address is used to determine which network a host or a node belong to. Alright, so let's move on and talk about public and private IP addresses. Now, IPv4 addresses are further classified as public or private, right? And public IP addresses are just the ones that are exposed to the internet that anyone can use, right? And then private ones are hidden from the internet and any other network. So you've got private ranges here in this table on the right? And you'll see that commonly, I bet. If you check your IP address right now on your computer, it'll probably come up as 192.168.0.0. And for larger organizations, it's probably going to start with a 10 dot, and for medium-sized organizations, it's probably going to start with a 172.16 if you happen to be on a local area network right now. All right, so there's also static and dynamic IP addresses. So IP addresses can be assigned statically, which means they're manually assigned to a host and so they don't change. And that's what static means. It means that it doesn't change. Now, dynamic in contrast means that it does change. And these types of addresses we automatically obtain from a server, the DHCP server, right? Which is pretty darn cool, right? So if you're moving from location to location, you're probably having IP addresses assigned to you automatically, and you may not even be aware of it. All right, so we're going to briefly talk about subnetting. Now, subnetting is simply the act of dividing a network into smaller subnetworks, okay? It's really like taking a big old pizza, right, and cutting it into slices. And the size of those slices really differ based on your objective, right? So you can make bigger ones or you can make smaller slices, right? Now, by default, all computers are like one big pizza. They're just one subnet or a network with no divisions involved, right? So we have to make sure that we subnet them, right? That's where the term subnet comes from, by the way, in order to make sure that we're efficiently using our IPv4 addresses. All right, so the last thing we'll discuss in this module is Internet Protocol version 6. Now, one thing I want you to know about Internet Protocol version 6, and I know that we talked about this in the earlier module where we talked about the details of the hexadecimal format, right? So you're familiar with that. Just know that this is the replacement for your IPv4, or will eventually replace the IPv4, right? Because it solves many of the limitations that the IPv4 has, including like address space and security, right? So this is a 128 bits system versus your 32-bit system provided by the IPv4. What blows my mind is that it provides 340 undecillion IP addresses in contrast to the 4.3 billion provided by the IPv4. All right, so that was the end of Module 6. Just a quick recap of our agenda here. We covered the Internet Protocol version 4, right? And we talk in detail about the address categories, right? We also discuss subnetting, which is separating a network into different subnetworks. And then we briefly discuss Internet Protocol version 6, okay? Thank you for joining me in this module. It was really interesting teaching you all these topics, and I'm looking forward to joining you in Module 7.